Hello students, hope you people are going through all the videos. So in the last video, that is video number 4, we were doing law of conservation of energy, which states that energy can neither be created nor be destroyed, what can be transformed from one form to another form. Or in other words, that during the freely falling bodies, the total energy or mechanical energy remains constant. Is that mechanical energy, that is equal to potential energy plus kinetic energy, it remains constant. Students, you have to keep one thing in mind, that in this case we had made one assumption that there is no air resistance. When the body is freely falling, there is no air resistance. If there will be air resistance, it means some of the energy will transform in terms of heat. So we are just ignoring it. So this law is only applicable in the absence of air resistance. So today we shall start with the next topic, that is conservation of mechanical energy in motion under gravity. For this we will draw one graph which represents the variation in kinetic energy and potential energy with the height above the ground. For this, just take axis and y-axis. This is x-axis, this is y-axis. Along the x-axis take height, that is above the ground, and along the y-axis take energy. Let at the ground the point is A. The point A is at the ground and the body is thrown vertically upward direction and it rises to a maximum height. Let that height is V. Means this is the maximum height. And let C is the midpoint. Means the distance between A and B is h, that is h, and the distance between AC and AB, that is hy2. Now first of all we will draw the graph of potential energy when the body is thrown vertically upward direction. Vertically upward direction. I am just taking the point A here, and then this is the midpoint C, and this is the B point, highest point. B is the highest point, and from the ground the height is h, at the C the height is hy2. Now the body is thrown from the point A in the vertical height B. So as we know that as the height increases, the potential energy increases and the kinetic energy decreases. So at point B, the potential energy will be maximum, mgh, and the kinetic energy will become 0. So let us draw the graph of potential energy here. The potential energy will increase. Means at point B, at the highest point, the potential energy is maximum, that is mgh. But since at point A h is 0, so here at point A potential energy is 0 and the kinetic energy is mgh. So when the body is thrown vertically upward direction with some kinetic energy, so the potential energy at point A is 0 because here the height is 0 and the kinetic energy is equal to mgh according to the law of conservation of energy. So at the highest point, when the body reaches at the highest point, for a moment it stops. For a moment it stops, it means that the kinetic energy becomes 0 and the potential energy becomes maximum mgh. And then again it starts falling down like this. So this is the graph of potential energy. Now we can draw the graph of kinetic energy. Now when the body falls down vertically downward direction like this, at point B the potential energy is maximum mgh and the kinetic energy is 0. As the body falls downward direction, its height decreases. Its height, just see that, its height decreases and ultimately it's before striking the ground the potential energy becomes 0 and the kinetic energy becomes maximum. And at the point C, the kinetic energy is equal to 1 by 2 mgh. Like mechanical energy, that is equal to potential energy plus kinetic energy. So at the midpoint, potential energy will be equal to mgh plus kinetic energy will be equal to mgh, and this will be equal to mgh. So first case we will take when the body is thrown vertically upward direction. We will take a case upward motion when the body is thrown vertically upward direction. So point A, at point, first of all we will take point A. At point A the height is 0 and at point C the height is h by 2 and point B the height is h. Now the kinetic energy, first of all the kinetic energy at point A, that is the maximum mgh, and the potential energy is 0 since the height is 0. And then at point C height is h by 2, so kinetic energy is equal to 1 by 2 mgh, and the potential energy, that is also equal to 1 by 2 mgh. Then at the maximum height B, the kinetic energy is 0 and the potential energy is equal to mgh. Now the next is downward motion. Again, downward motion means from B to A. So first of all, at point B the height is h, at point C the height is hy2, and at point A the height is 0. So kinetic energy at point B is 0 and the potential energy is equal to mgh. Then at C the kinetic energy is equal to 1 by 2 mgh and the potential energy is equal to 1 by 2 mgh. So at point A, kinetic energy is the maximum before touching the ground, that is mgh, and the potential energy is 0. So students, these are the conservation of mechanical energy in motion under gravity. One case we have taken when the body is thrown vertically upward direction, and another case we have taken when the body is thrown vertically downward direction. So during the freely falling bodies, either in the upward direction or a downward direction, we have seen that the total energy or the mechanical energy that remain constant, that is mgh. So once again, in this case, we have ignored the force of friction between the body and air. So in fact, during the fall, some of the kinetic energy will change into the heat energy due to friction, and it will get dissipated in air at the ground C. The kinetic energy will be less than mgh. So don't forget students, we are just ignoring the external force such as friction due to air. Although the total sum of energy of all kind is always same or conserved. So let us move to the next topic, that is application of principle of conservation of energy to a simple pendulum. Application of principle of conservation of energy to a simple pendulum. So first of all, this is the rigid support and a pendulum is suspended with the help of inextensible string or thread. This is the bob and this is the inextensible string, and this is the rigid support. Now first of all, this pendulum is at position A, or you can say that it is in resting position. Now when it is displaced to one side and then released, it swings from one side to another side, reaching equal distance and equal height on either sides. Again, we are neglecting the force of friction between the bob and the surrounding air. Now, let A be the resting position, or you can say that A is the main position, and at A, the potential energy is 0 and the kinetic energy is mgh. In fact, Point to be noted, students. In fact, at the mean position, the bulb has the minimum potential energy. Since we are interested only in the change in potential energy as the bulb swings, so we may assume it to be 0 at the mean position. So once again, students, just listen to me very carefully. Although at the mean position I have taken potential energy 0 and kinetic energy mgh. But in fact, the bulb has the minimum potential energy at the mean position. Since we are interested only in the change in potential energy as the bulb swings, so we may assume it to be 0 at mean position. Now when the bulb is displaced to B, let it is displaced to side B. Let the bulb gets raised by a vertical height h. So its potential energy increases by mgh. Now let this point is B. So since at the highest point the potential energy will be equal to mgh and kinetic energy will become 0, because after reaching the highest point, that is B, the bulb will come to rest for a moment and then again moves back from B to A, then A to C. Again the bulb gets raised by a vertical height h. Again C is the extreme position. So at the extreme position the potential energy is equal to mgh and the kinetic energy is 0. So its vertical height decreases h to 0. So its potential energy decreases from mgh to 0 and gets converted into kinetic energy. So we can find the velocity of the bulb. Since the potential energy is transferred to kinetic energy, we can say that kinetic energy is equal to mgh. Kinetic energy is equal to 1 by 2 mv square, and this is potential energy, and this is equal to mgh. M and m get cancelled, so v square is equal to 2gh and v is equal to under root 2gh. So at the point A, the bulb acquires velocity b is equal to under root 2gh. So it moves forward C. So at the point C, when the bulb gets raised by a vertical height h above the point A, again it acquires the potential energy and its kinetic energy becomes 0. So the bulb momentarily comes to rest at the point C. What? Due to the force of gravity, the bulb moves back from C to A. So thus during the swing at the extreme position B and C, the bulb has only the potential energy, while at the mean position it has only kinetic energy. And this is strictly true only in vacuum, where there is no force of friction due to air. So with this, students, your chapter is completed. numericals are given. 6 numericals are there for this topic. I'm just going to give you my WhatsApp number. If you have any kind of doubts, you can let me know, and in the next video, first of all, I will take your doubts. If you have any doubts in any topic, any numericals or any logical questions, you can ask to me, and definitely in the next video I will remove it. Then after we will start with the next chapter, that is machine. So thank you very much. So my WhatsApp number is 8196002446. 8196002446. So thank you very much.